There is a moment in history when a nation realizes it is not prepared for what is to come. A moment when reality knocks on the door with devastating force and demands an immediate response. For the United States, that moment came in 1940, when the world was burning and American war machines were dangerously vulnerable. This is the story of how America discovered that its machines lacked the necessary protection to face the approaching conflict, and how a steel company from Pennsylvania became the salvation of an entire nation. When we think of World War II, we imagine epic battles, brilliant strategies, and heroic sacrifices. But we rarely think about steel. We rarely consider that before any tank rolled onto the battlefield, before any ship set sail for combat, someone had to figure out how to make them strong enough to protect the lives inside them. This is a story about engineering, determination, and the race against time that defined the fate of millions. If you're enjoying this story, subscribe to the channel and leave a comment saying what time you're watching this video. Now, let's go back to 1940 when America faced a crisis that few know about. The year 1940 began with a Europe already consumed by war. The Nazi war machine had demonstrated terrifying efficiency, conquering nation after nation with a speed that left the world stunned. France, considered one of the greatest military powers on the continent, was about to fall. Britain fought alone against the relentless advance. And the United States watched, trying to remain neutral while President Roosevelt knew, deep in his soul, that neutrality would not last forever. At that critical moment, the American military began to evaluate their own capabilities. What they discovered was alarming. American tanks, warships, armored vehicles that were supposed to protect soldiers in combat, all shared a fatal vulnerability. They did not have armor resistant enough to withstand the modern weaponry being used on European battlefields. America had quantity, had will, had men willing to fight, but did not have adequate protection to keep them alive. Armor is not just thick steel. Anyone who understands even minimally about metallurgy knows there is a fundamental difference between common steel and high-quality armored steel. Armored steel needs to be incredibly hard to resist projectile penetration, but at the same time needs to have enough toughness not to shatter on impact. It is a delicate balance, a chemical and physical dance that few in the world had mastered. And in 1940, the United States was not among those few. Military specifications required what was called hardened armor plate, a specific type of steel treated through complex thermal processes that dramatically increased its surface hardness while maintaining a more ductile core. This material was essential, not optional. Without it, a tank was extremely vulnerable on the battlefield. Without it, a warship faced very high risks in combat. The American steel industry was vast and powerful, but was focused on structural steel, railroad tracks, construction beams. The production of military-grade armored steel was a specialized art that had been neglected during the years of peace. After all, who needed armor when there was no war? Who would invest in expensive and complex processes when there was no demand? America had become complacent, and now the price of that complacency was about to be paid. The War Department began making frantic calls. They needed suppliers, they needed production capacity, they needed someone who could deliver thousands of tons of hardened armored steel on a deadline that seemed impossible. The major steel companies were consulted. Some said they would need years to develop the capability. Others said they simply could not do it. And then someone mentioned Bethlehem Steel. Bethlehem Steel was a giant of American industry, founded in 1857 in Pennsylvania. For decades, the company had built a reputation for excellence in metallurgy, producing everything from railroad tracks to skyscraper structures. But what few knew was that Bethlehem Steel had maintained a small experimental division that worked with advanced heat treatments and specialized metallurgy. It was almost an expensive hobby, a luxury that management allowed because you never knew when it might be useful. In 1940, that seemingly useless investment was about to save the nation. When military representatives arrived at Bethlehem Steel facilities, they did not have high hopes. They had been disappointed so many times that they were beginning to believe that America simply did not have the technical capacity to produce the necessary armor. But something different happened that day. Bethlehem engineers not only said they could do it, they explained exactly how they would do it. The process of creating hardened armor plate is a marvel of metallurgical engineering. It begins with careful selection of the steel's chemical composition, precisely adjusting the percentages of carbon, nickel, chromium, and molybdenum. Each element plays a crucial role in the material's final properties. Too much carbon and the steel becomes brittle. Too little carbon and it does not achieve the necessary hardness. It is a recipe that demands perfection. After being cast and molded to the correct dimensions, the steel goes through a process called quenching. The plate is heated to extremely high temperatures, above 1,000 degrees Celsius, until its crystalline structure transforms. At that critical point, the plate is rapidly cooled, usually plunged into oil or water. The thermal shock freezes the structure into an incredibly hard form, but also dangerously fragile. This is where the tempering process comes in, perhaps the most delicate step of all. The hardened plate is reheated to a carefully controlled temperature, not as high as before, but enough to relieve internal stresses and give the material a bit of flexibility. It is finding the exact point where hardness meets toughness, where strength meets resistance. Miss by a few degrees and the entire plate can be ruined. Bethlehem Steel engineers had spent years perfecting these processes on a smaller scale. Now they needed to do something that had never been attempted before: scale this artisanal production to massive industrial levels. They were not talking about making a few plates per month. The War Department needed thousands of tons, and needed it quickly. The first task was to build the furnaces. Not just any furnace, but gigantic furnaces capable of heating steel plates weighing several tons uniformly. Uneven heating would mean uneven properties, and uneven properties would mean fatal weak points in the armor. Bethlehem Steel invested millions of dollars of the time in new equipment, betting everything on the ability of its engineers. While construction was happening, teams of metallurgists worked 24 hours a day refining the exact specifications. Each batch of steel was tested to destruction. Plates were hit with high-velocity projectiles to see how they resisted. Samples were examined under powerful microscopes to check the crystalline structure. Technical documents accumulated in piles while scientists pursued perfection. There were failures, many failures. Entire batches of steel that did not meet specifications had to be discarded. Furnaces that cracked under extreme thermal stress. Cooling systems that did not work properly. Each problem was a puzzle that needed to be solved, and the clock did not stop running. Europe was falling, and America needed to be ready. One of the biggest challenges was the pure scale of the operation. Producing a perfect armor plate in the laboratory is one thing. Producing hundreds of them per day, each with the exact same properties, is completely different. Variability needed to be eliminated. Each furnace needed to operate at the same temperature. Each quenching tank needed to cool at the same rate. Each process needed to be as consistent as a clock. Bethlehem Steel implemented quality controls that were revolutionary for the time. Each plate received a serial number. Samples from each batch were tested and results meticulously documented. If a plate failed the tests, they could trace exactly which furnace it came from, which batch of raw material was used, who was operating the equipment on that shift. It was a level of traceability that the steel industry had never seen before. The factory workers became an essential part of this effort. Many of them understood that the steel they were producing was not just another product. The steel would save lives. Each plate that left the production line could be the difference between a soldier coming home or not. This awareness created a culture of excellence and care that permeated every aspect of the operation. Stories began to circulate about the workers' dedication. Men who worked double shifts without complaining. Engineers who slept on cots in the factory to be available at any time. Entire families who moved to Bethlehem, Pennsylvania, to be part of this monumental effort. It was patriotism in its purest form, translated into tons of hardened steel. By mid-1941, Bethlehem Steel was producing armor plate in quantities that seemed impossible just a year before. The warships being built in American shipyards now had the protection they needed. The tanks that would come out of Detroit factories would have a real chance of survival on the battlefield. America was arming itself, and Bethlehem Steel was at the heart of this effort. But the real test would come in December 1941, when Pearl Harbor was attacked and the United States was thrust into the war. Suddenly, it was no longer a question of preparing for a distant possibility. It was a question of national survival. And thanks to the tireless work of Bethlehem Steel and its thousands of workers, America had the tools it needed. The Sherman tanks that landed in Normandy had Bethlehem Steel armor. The destroyers that patrolled the Atlantic against German submarines had Bethlehem Steel armor. The armored vehicles that carried soldiers through North Africa had Bethlehem Steel armor. In every theater of war, in every major battle, Bethlehem Steel was there, silently protecting lives. It is important to understand what this armor really meant in practical terms. A cannon projectile hitting an inferior quality armor plate could penetrate it completely, seriously compromising safety inside a tank or ship. But a properly hardened armor plate could deflect the same projectile or, at minimum, absorb enough energy to prevent complete penetration. This difference, measured in millimeters of steel and degrees of hardness, was literally the difference between life and death. Field tests confirmed what engineers already knew. American armor was working. Reports came from the front describing tanks that had been hit multiple times but continued operational. Ships that survived direct attacks and could return to battle. Each of these survival stories was a silent testimony to the work done in Pennsylvania factories. But the story of Bethlehem Steel during the war is not just about technical success. It is also about continuous innovation. As the war progressed, enemy weaponry became more powerful. The Germans developed more effective anti-tank cannons. The Japanese improved their torpedoes. The arms race never stopped, and this meant that armor also needed to evolve. Bethlehem Steel metallurgists worked constantly to improve their formulations. New alloys were tested. Heat treatment processes were refined. Plate thickness was increased in critical areas. Each incremental improvement represented more protection for American soldiers. It was a silent battle fought in laboratories and furnaces, as crucial as any battle in the field. Production capacity also needed to continue growing. More furnaces were built. More workers were trained. The Bethlehem factory operated 24 hours a day, 7 days a week, without stopping. The noise of hammers and the glow of furnaces never ceased. It was an operation of epic proportions, driven by the urgency of war. Other American steel companies eventually also began producing armor, learning from Bethlehem Steel's pioneering methods. This was necessary because the demand was simply too large for a single company to meet. But Bethlehem remained leader in quality and innovation, setting the standards that others followed. The logistics of transporting these enormous steel plates from factories to shipyards and tank factories was another massive operation. Special trains were designated exclusively for armor transport. The plates were so heavy that normal railroad cars could not carry them. New hoisting and handling systems had to be invented. Every aspect of the supply chain needed to work perfectly. There were moments of crisis. On one occasion, a defect in the tempering process went unnoticed and several hundred plates were shipped before the problem was discovered. All had to be called back and reprocessed, causing a significant delay in production. It was a devastating moment, but also demonstrated the unwavering commitment to quality. No inferior plate would be allowed, no matter the cost. Engineers learned from each mistake. Double-checking systems were implemented. New non-destructive tests were developed to detect internal defects without destroying the plates. Ultrasound technology, still in its infancy, was adapted to inspect the steel. Each innovation made the final product more reliable. As the war approached its end in 1945, Bethlehem Steel had produced millions of tons of hardened armor plate. The exact number remains classified to this day in some aspects, but conservative estimates suggest the company was responsible for more than half of all high-quality armor used by American forces during the war. It was a monumental contribution to the war effort. But perhaps even more important than the numbers is the human impact. How many lives were saved by this armor? How many soldiers returned to their families because the steel held when it needed to hold? How many battles were won because American equipment could take punishment and keep fighting? These are questions impossible to answer with precision, but the answer, undoubtedly, is in the tens or even hundreds of thousands. After the war, Bethlehem Steel continued to be a pillar of American industry. The metallurgical expertise developed during the war years was applied to countless other areas. The company helped build America's post-war infrastructure, from bridges to skyscrapers. But those who worked there during the critical years from 1940 to 1945 always knew they had been part of something special. War veterans occasionally visited Bethlehem Steel facilities, wanting to see where the armor that protected them had been made. Some brought pieces of shrapnel that had been deflected by that steel. Others simply wanted to shake the workers' hands and say thank you. These were moving moments that reminded everyone that behind each ton of steel was a deep human purpose. The story of American armor in 1940 is a story about recognizing a crisis and responding with determination and ingenuity. It is about ordinary people doing extraordinary things under immense pressure. It is about the intersection of science, industry, and human need. And it is a reminder that sometimes the most important victories happen far from battlefields, in factories and laboratories where men and women work to make the impossible possible. When we look back at that crucial year of 1940, we can clearly see how America was unprepared. The war machines were vulnerable, industrial capacity was inadequate, and time was running out. But we can also see the response. We can see Bethlehem Steel taking on a challenge that seemed insurmountable and transforming it into reality. We can see thousands of workers dedicating their lives to a greater purpose. We can see American innovation at its best. This story also teaches us about the importance of preparation and investment in capabilities that may seem unnecessary in times of peace. Bethlehem Steel's small experimental division that worked with advanced heat treatments seemed like an expensive luxury before the war. But when the crisis came, it was exactly this capability that made the difference. It is a lesson that remains relevant today. We never know when specialized expertise will become critical. The advanced metallurgy developed to create war armor also had lasting impacts on civilian applications. The same principles of heat treatment and quality control were applied to automotive components, construction structures, and countless other products. The knowledge gained during those intense years of war production continued benefiting society long after the conflict ended. It is fascinating to consider how material science has evolved since then. The armored steel of 1940, although revolutionary for its time, would be considered primitive by modern standards. Today, we have composite materials, advanced ceramics, and exotic alloys that offer even better protection with less weight. But all these advances are based on the fundamentals established by those early armor pioneers. The challenges faced by Bethlehem Steel engineers were both human and technical. They needed not only to master the physics and chemistry of steel, but also to manage enormous teams, coordinate complex logistics, and maintain morale high during years of exhausting work. It was engineering in the broadest sense of the word, combining technical knowledge with leadership and vision. Documents from the time reveal the intense pressure under which these people worked. Urgent telegrams from the War Department requesting production acceleration. Battle reports showing the desperate need for more armor. Each message was a reminder that the work was not just important, it was literally a matter of life or death for soldiers on the battlefield. The collaboration between government, military, and private industry during this period established a model that would continue to be used for decades. The partnership between Bethlehem Steel and the War Department demonstrated how the public and private sectors could work together effectively when facing a common goal. It was not always smooth. There were disagreements and frustrations, but in the end, it worked. Looking at photographs of Bethlehem Steel facilities during the war years, we see an industrial landscape of almost mythological proportions. Giant furnaces glowing in the night, cranes moving massive steel plates, workers small compared to the machinery around them, but essential to making everything work. It was American industrialization at its most powerful expression. Women also played crucial roles in this story, especially as more men were drafted for military service. They worked in furnaces, operated cranes, performed quality inspections, and kept production running. Many of these women discovered capabilities they never knew they had, breaking barriers and proving they could perform work considered exclusively male. The community of Bethlehem, Pennsylvania, was transformed by the war. The population grew dramatically as workers arrived from across the country. New housing was built quickly. Schools were expanded. The small industrial town became a vital center of the American war effort. and local residents were proud of the role their city was playing. After the war ended, there was a period of adjustment. Demand for armor dropped drastically. Many workers had to be laid off. Bethlehem Steel needed to find new markets for its expanded capabilities. It was a difficult time, but the company survived and prospered, applying its skills to new peacetime challenges. The lessons learned during the armor crisis of 1940 continued to influence American defense policy. The government learned the importance of maintaining at least some defense industrial capacity even during peacetime. Never again would America be caught as unprepared as it was in that critical year. It was a lesson learned through great sacrifice and determination. Today, when we visit the sites where Bethlehem Steel factories once operated, we find mostly silence. Many of the facilities have been deactivated or demolished. The American steel industry changed drastically in the following decades. But the memory of what was accomplished there remains, preserved in museums, historical documents, and in the stories told by veterans and their descendants. There is something deeply human in this story. It is about people facing an existential threat and discovering within themselves the capacity to overcome the impossible. It is about engineers refusing to accept limitations. It is about workers sacrificing their comfort for the greater good. It is about a nation finding its strength when it needed it most. The armor that Bethlehem Steel produced did not win medals. There are no monuments dedicated to steel plates, but every tank that resisted an attack, every ship that survived a torpedo, every soldier who came home, they all owe part of their survival to that hardened steel. It is a silent but powerful legacy. When we think of heroes of World War II, we correctly think of the soldiers who fought on the beaches, the pilots who flew dangerous missions, the sailors who faced stormy seas and great challenges. But we must also remember those who made these victories possible through their work in factories and laboratories. They also served, they also sacrificed, they also deserve to be remembered. The story of American armor in 1940 is ultimately a story about hope. Even when the situation seemed desperate, even when American machines were vulnerable and unprepared, there were people willing to believe that a solution was possible. This belief, combined with hard work and ingenuity, transformed a potentially catastrophic crisis into a triumph of human determination. As we reflect on these events from more than 8 decades ago, we find lessons that remain relevant. The importance of preparation, the value of technical expertise, the need to invest in capabilities even when there is no immediate threat, the capacity for rapid mobilization when crisis arrives, and above all, the power of the human spirit when united by a common purpose. Bethlehem Steel was not perfect. It was a company that sought profit, that faced labor challenges, that made mistakes. But when the nation needed it, it was there. When American soldiers needed protection, it delivered. And for that, it deserves its place in history, not as an example of corporate perfection, but as an example of what is possible when technical capability meets urgent need. America's machines were without hardened armor in 1940. It was a dangerous vulnerability, a potentially fatal flaw in the nation's preparation. But thanks to Bethlehem Steel, thanks to thousands of dedicated workers, thanks to brilliant and visionary engineers, that vulnerability was corrected. The steel was hardened, the machines were protected, and countless lives were saved. This story reminds us that behind every great historical event there are thousands of smaller stories, equally important. Behind every battle won exists the logistics that made it possible. Behind every protected soldier exists the work of someone who will never see the battlefield. And that all these efforts, large and small, visible and invisible, combine to create what we call history. May we honor the memory of those who worked in the forges and furnaces of Bethlehem Steel. May we learn from their dedication and their sacrifice. And may we recognize that the true strength of a nation lies not only in its soldiers, but in all those who contribute, each in their own way, to protect and defend what is precious. To the Lord God, who guides human hearts in times of need and inspires the courage and wisdom necessary to overcome the greatest challenges, be all glory and gratitude for empowering men and women to accomplish the extraordinary when the moment demands it.